Dear students, how are you all? Are you happy? Are you safe? Great to hear from you. We learned something about chemistry in everyday life. One of the interesting topic, I believe. And we learned something about surface chemistry also. A lot of things about catalysts, colloids, and different applications of colloids and catalysts we learned. And in chemistry in everyday life, the chemicals which are useful for us in various forms we learned. We talked about the soaps, detergents. So, we are going to learn one more topic in organic chemistry. That is the first topic in organic chemistry. And in volume 2, this is unit number 11, which is closely related to our chemistry in everyday life. Few of the reactions will be repeated here also, and you will find it very easy for you to learn, because in 11th standard we learned organic chemistry as the last part. I hope you are familiar with some of the important basics in organic chemistry. Today, before starting this chapter also, we will discuss some of the organic chemistry basics. Don't be worried. So today's topic is unit number 11, Hydoxy compounds and ethers. What are hydroxy compounds and ethers? Can you have some guess out of the name given? Yes, you are right. That is, the word hydroxy, if you break, you can see first part talks about hydrogen, second part talks about oxygen. If you join them, we will be learning about compounds with the OH group as functional group. Otherwise, those compounds are also called as alcohols. So today's learning is going to be about alcohols and ethers. They are almost like co-brothers. So we'll be learning about them. Very interesting area. And alcohols, as you know, we are talking everywhere nowadays, because the COVID-19 pandemic is all around, and whenever they talk about keeping ourselves safe, cleansing our hands, we learned in chemistry in everyday life about soaps and their usage. How do they clean? Similarly, in sanitizers, they talk about the presence of alcohols. Yes, they talk about 65 to 70%, even more than 70% alcohol presence in a sanitizer will do a very good job in fighting against this dangerous virus. So, always when we talk about alcohols, don't always imagine about beverages alone. We have to talk about alcohol. They are widely spread all around the world, and they are useful to us in many fields. Even our body too has a lot of alcohols. Yes, the cholesterol alcohol, which is a very important component in the cell membrane, is a kind of alcohol. When we talk about the main substance in vitamin A, that is retinol, you can have a guess. Vitamin A, we talk about eye-sex. Good. So retinol is presence in our body, or we take in the form of food items. The elders used to suggest the younger ones about the intake of more of carrots, more of greens, and more of papaya. All of them will supply vitamin A to our body, that is retinol to our body. That will enhance the vision capacity of human beings. And we talk about cleansing our body. We use some of the soaps, and particularly Dettol, Savlon, they talk about soaps. And there they add the alcohol as an additive, as a disinfectant. We use some of the disinfectants in the toilets too. So all of them are having the behavior of killing the germs and bacteria and viruses. So it is a need of the hour. And alcohol's job doesn't stop over there. Methanol is a widely used solvent in most of the paint, varnishes and the removers of stain. They talk about alcohol. If you want to remove even your nail polish, and we are talking about alcohol combination with acetone or the materials related to alcohols. And now government is having a strong opinion of manufacturing a lot of ethyl alcohol to have a substitute for petrol too. That means they are talking about power alcohol. That means alcohol can be mixed along with the petrol so that the calorific value will also be good, and the fuel dependency to other nations will get reduced, pollution level will come down. So that is another area. When we talk about alcohols, we can think of extraction. We learned in organic chemistry 11th standard. So some of the important organic chemicals are available, and the herbs are having a lot of chemicals which are medicinally important. All those chemicals are mostly made up of organic molecules. They don't dissolve mostly in water. So, but we need to form them as medical formulations in the form of syrups or tonics. So, we have to add alcohol which has the better capacity to dissolve the organic materials, even the polar materials in organic too, and then it brings in the form of tonics. That's how we can't say that we haven't taken alcohol in our lifetime, because even the syrups, tonics, they contain alcohol. And some of the times you can see the elder ladies will sit in front of the TV and cry watching the TV serials. Yes, there too there is a presence of alcohol. And our people cry without alcohol, but those who are acting in the serials and movie for a spontaneous crying artificially, they will apply glycerin and they cry. And when we talk about glycol, it is an antifreeze in automobile radiators. We'll be learning about that. And when we talk about glycerol, it is also used in stamp pad and moisturizing creams. They contain glycerol. And phenol is a wonderful compound. Benzyl alcohol, a lot of esters and perfumes, we talk about all of them. So dear students, alcohols and ethers are very important compounds for us. And before going further deep into that alcohols and ether category, let us have some understanding about the basic concepts of organic chemistry. Because organic chemistry, when we talk about some of the chemicals, our boys, they have some kind of aversion. And it's not true. Organic chemistry is one of the easiest area where you can score full marks. And most often the organic reactions can be easily recalled because they have a common strategy. What I mean to say is, whenever we talk about an organic chapter, it goes with this strategy. That means they give an introduction about that particular lesson, most probably a functional group. And if suppose we talk about an organic compound, the simplest one, which is an hydrocarbon. I hope boys you can name it easily. Only one carbon atom is attached to 4 hydrogen atoms. So this compound is the simplest hydrocarbon called as methane. And methane has 4 hydrogens, all of them are covalently bonded to carbon atom with a sigma bond. All that will be learning. Because as you know, we have a carbon atomic number is 6. If you go for electronic configuration, 1s2, 2s2, 2p2. That is, this is K shell and this is L shell. So outermost shell carries 4 electrons. That too, if you elaborate it, s orbital we have 2 electrons, and in p orbital 2 unpaired electrons are available. Then you may be asking a question, how come the valency of carbon is 4? There are only 2 unpaired electrons available. Most often carbon goes for excitation or promotion. So from the 2s orbital, one of the electron will jump to 2p orbital. So after the jump, you can see all these available orbitals will carry 1 electron, because this paired electron has jumped over here. So now you could closely see the valency of carbon is 4. That's why this is the main basic you have to understand. Carbon's valency is always 4, and since it is having 4 as valency, losing electron or gaining electron is not an easy job to reach the octet. So it is trying for sharing of electron. He is a wonderful person. Why carbon is useful in organic chemistry, and it is the most known element in organic chemistry because he has the capacity to share things, and because of that he is inviting a lot of his own friends. So many of the elements they join with the carbon, and the organic chemistry every day it is growing and growing. And if you closely see this particular carbon atom, since it is having 4 of the electrons and hydrogen has only 1 electron, so they go for 4 of the sigma bond, CH4. So when they have single bond, they have learned in organic chemistry basics, the compound's name will end with the ane. They are otherwise called as a saturated compound. Saturated hydrocarbons will have the name ending with the ane. Similarly, when we talk about double bonded, these are all single bonded compound. We talk about double bond and triple bonded compound. We talk about unsaturated compounds. Unsaturated means they will have double bond and single bond. There will be 1 sigma bond and a pi bond, and in this case 1 sigma bond and it has 2 pi bonds. So from the name itself you can understand unsaturated, they need more people. So what happens, they will break their bond easily and attach 2 more people. Here in alkyne they will break 2 of the pi bonds. So we will be learning about all that in later part. Now you have to understand these are saturated compounds, will have only single bond and they will end with the A, and unsaturated compounds they have a double and triple bond. These are the compounds will end with the ene, alkenes, and these are the compounds will end with the ine. It's better with the basics of organic chemistry. Your learning becomes interesting and they will start going very fast in learning one by one the concepts. As I told you, these hydrocarbons will carry only carbon and hydrogen. When we remove one of the hydrogen and in the place, if you attach one OH group, then we talk about hydroxy compounds, otherwise they are called as alcohols. And in that place, if you go for OR group, in the place of hydrogen you attach OR group, then we talk about ethers. And if you go for CHO in the place of hydrogen, then aldehydes. And if you go for C double bond O and R group, then we talk about ketones. Both these aldehydes and ketones are coming under carbonyl compounds. Carbonyl, C double bond O group is the main group that will make up the functional group. And in this place you go for C double bond O, H, then we talk about carboxylic acids. In your home you have vinegar, acetic acid, and bites, and afterwards you feel the irritation for some time because of formica and formic acid, benzoic acid, and we talk about a lot of the organic acids. Then COOH is a functional group. And if you have C double bond O, R group, then we talk about esters. These are esters. And when we attach, now you can see the presence of, till now we were talking about carbon, and it was having oxygen and hydrogen as its own friends. He's inviting one by one. Now he's going to invite a nitrogen also. Then we talk about organic nitro compounds, and sometimes organic amino compounds, and we talk about nitriles or cyanides. And when we react all these compounds with benzene diazonium chloride, and different functional groups are possible, that also we'll be learning in that. And then if we have organic group, hydrocarbon, hydrogen is removed and X is added. Halogens. Halogens can be fluorine, chlorine, bromine, iodine. If suppose an organic compound is added with the halogens, then Rx will be the general formula. Alkyl halides. All these are interesting areas in organic chemistry. Now you, as I told you in the beginning of introductory class for chemistry, I told you the functional groups are classified into different units. That's all. So when we talk about alcohols, OH as functional group and OR as added in the place of hydrogen, then we talk about today's topic, that is hydroxy compounds and ethers. And this next topic we'll be learning as a carbonyl compound, where we talk about aldehydes and ketones. And carboxylic acids and esters are put together as a carboxylic acid, and they are the ones which are very useful in the form of smelling agent and preservatives. All that we'll be learning. And organic nitro compounds are nitrogen compound. Then in organic chemistry we will be talking about biomolecules, the molecules which are available inside our body. Most of them will have combination of alcohols, ketones, and polyhydroxyaldehydes and ketones. Then we talk about amides, proteins, amino acids, lipids. All of them will come under biomolecules, combination of all of them. Then, as you know, the last chapter we learned as a previous discussion as chemistry in everyday life, where the real time we have an interaction with all the chemicals available, and we started manufacturing new chemicals and started incorporating them. One of the compound we learned as polystyrene is one of the product. Recently there was an accident in Visakhapatnam, and there you can see the chemical which is synthesized into a new chemical in a very useful manner. They will do a lot of good for the human being. Sometimes if they are handled carelessly or recklessly, they may become life-threatening for the human beings. That's why whenever you come to the laboratory, we are advising you to be very, very careful with the chemicals. Sometimes they may be looking very quiet, calm, colorless. Only when even you take hydrochloric acid or sulfuric acid, they look very calm inside the bottle. When unfortunately they fall on to our belongings like shirt or even sometimes skin, sometimes dangerously to the eyes, the damage will be permanent. And you would have seen the alkali metals reaction with even water. Sometimes explosive, even alcohols will be learning. One part of alcohol always we believe beverages area, and other part I told you a lot of uses of alcohol and different classes of alcohols, and sometimes alcohol can be used to produce explosives too. So glycol on nitration will give an explosive, glycerol on nitration will give an explosive, phenol on nitration will give an explosive. We will be learning very interesting compounds. As you know, we will be talking about TNT, trinitrotoluene, and we will be talking about TNB, trinitrobenzene. And in this chapter about picric acid, and we will be talking about glyceride, trinitrate. All these are the name looks they are quite good people, but they are explosive in nature. So the basic ideas are known to you. Learning organic chemistry become interesting. As I told you in the beginning, they give some details about the introduction. What are that particular alcohols or ethers, what are aldehydes. Then after that they talk about the nomenclature, naming part, and as you know there are different namings available like trivial naming, common naming, IUPAC naming or IUPAC naming they call. All these names they will be talking, then only you can understand. And then they talk about their structure of the functional group and why are they reacting such a way. And then they may be talking about their physical properties, and they talk about first preparation of that particular functional group to organic compound, then physical properties. Physical properties mean they talk about boiling point and they talk about hydrogen bonding and whether they are volatile or they are solids, liquid or gases. And then their nature, smell, all that are physical appearance. Physical appearance for a few of the compounds, as I told you now, they may be quite good and smooth. And how do you understand this is the nature of the compound? Only when you react them chemically, few of the information, these are chemical properties. After learning chemical properties, we will be talking about the application of that particular compound or uses of those compounds. Sometimes we will go for derivatives of those compounds. So this is how the organic chemistry chapters are being designed. And what is another interesting thing is one lesson's chemical property may become preparation in the next lesson, maybe another lesson. Let me give you an example. If you are learning an oxidation reaction in hydroxy derivatives, that will be a preparation of aldehydes or ketones in a carbonyl compound. So one place you learn organic chemistry, particular preparation or property, that may be repeated in the next lesson too. And another advantage is most of the organic chemistry problems coined, you can expect them interlinking different chapters. Sometimes it may also happen. In the same lesson they may ask question or they may give clues or one more product can be from the next chapter too. So if you have a good understanding of all the chapters, solving the organic chemistry problem will become very easy. And next advantage of learning organic chemistry is 1 or 2 times of deep learning with understanding, because organic chemistry has some basic ideas. They will be repeated always. For example, I will name few of them. Whenever you talk about organic chemistry reaction, they talk about oxidation, reduction. Most probably these are all familiar terms to you. They talk about hydration. See, look at the name, you can understand. Hydration means they are adding water. And dehydration, that means they are removing water. Hydrolysis, add water and split. And they talk about hydrogenation, that means they are going to add hydrogen. Dehydrogenation, that means they are going to remove hydrogen. And they are going to talk about oxidation, maybe addition of oxygen or removal of hydrogen. Reduction can be removal of oxygen or addition of hydrogen. Or they may be talking about halogenation, means they are going to add halogens like as I told you just now, fluorine, chlorine, bromine, iodine, all these things. We talk about halogenation. And they may be talking about hydroxylation, addition of OH group. And dihydroxylation, 2 OH groups can be added. Sometimes they will be talking about hydrohalogenation, that means hydrogen will be added and also halogen will be added. And only when you go through these reaction by say like looking at the name of the reaction and the whole story, you can talk about that particular equation or the content. And sometimes when they are in the same lesson, if you know the basics of all these things, they are not going to change. And for example, if you want to add water, what will be the reagent? Some boys may ask, sir, reagents are my problem, which agent has to be added? Whether I have to go for concentrated sulfuric acid or dilute sulfuric acid. And if you know the basics, it's all very simple. See, sulfuric acid is going to be same only, but in sulfuric acid there are 2 things available, concentrated or diluted. Dilute sulfuric acid, just look at the name dilute, that means more amount of water. Just for your example, I am giving 90% of water is there, maybe sulfuric acid I am talking about 10%. In a dilute condition, sulfuric acid is 10% and water is 90%. That means more of water. Suppose if you want to go for hydration, that means addition of water, you have to prefer only dilute sulfuric acid. And in case if you are going for dehydration, that means removal of water, then you have to talk about concentrated sulfuric acid. Just for example, I am giving you concentrated sulfuric acid will have 90% of sulfuric acid and 10% of water. And in that case, he will have, just for example, I gave you the percentage, in that case, it has the capacity to remove water. You will pull out the water out of the organic compound. In such case, it will behave like a dehydrating agent, that means it will remove water. So, by looking at the name of the compounds, most of the organic reactions can be learned. That's why I am telling you, organic chemistry learning is easier, and every chapter there will be a common format and common reactions will be there, and one by one if you try to understand them and try to adopt the same strategy to other chapter 2, then learning becomes easy and less burdening. Next, when we are talking about hydroxy compounds, As I told you, these compounds can be called as alcohols too. And now there is a big question to some of you. Like OH, you said, okay sir, OH, right? And OH is an hydrogen oxygen hydroxy, right, or alcohol, fine. But sometimes when joins with sodium, you are calling it as hydroxide. Magnesium hydroxide, calcium hydroxide. But here you are talking the same OH group as alcohol. Why? In some places it is called hydrin, cyanohydrin, chlorohydrin, bromohydrin. So you have to understand the nature of these organic compounds, and they mostly go for covalent linkage, the sharing of electron. I told you about carbon's nature. And here the covalently bonded oxygen and the hydrogen and the type of compound formed, we have to call them as alcohols. And in the case of sodium, it goes for an ionic linkage, and the negative part of the molecule, OH, we call it as a hydroxide. So we have to look into with whom he is linking the OH group. If it is a metal or inorganic compound, mostly we talk about hydroxide. In case it is joining with an organic group, this group or group can be an alkyl group. And you may have a question now, what is an alkyl group? Alkyl group can be methyl or ethyl group. And what is that? See, like CH4, I am going to write that methane as CH3 and H, that is CH4. In CH4, only one carbon atom is available. Then we learned the basics. It has to start with the meth. And I am removing one of the hydrogen, and then you have to add, include one Yl. Minus hydrogen, include Yl. So it is methyl. And similarly, if you have CH3 and CH3, this is ethane. As you know, the naming, two carbon atoms are there. It has to start with eth. Just now I told you, saturated compounds will have single bond. If it is having a single bond, the name has to end with the ane. Then it is ethane. So ethane is CH3, I remove one of the hydrogen, and that particular group you have to call ethyl, because two carbon eth, no hydrogen, one hydrogen is missing, Yl. So this is how we go for the basic ideas. Suppose we go for the next one, CH3, CH2 and CH3. And you look carefully, 3 carbons are available. We learn the basics. Their compound has to start with the pro. And I am removing one of the hydrogen, then you have to add a Yl. So it is propyl. Similarly, 4 carbon butane, 1 hydrogen you remove, butyl. 5 carbon pentane, remove another hydrogen, then called as pentyl. 6 carbon hexane, remove 1 hydrogen, add Yl, then you call it as hexyl. Like that it goes on. So this R group, generally they call them as the alkyl group. Alkyl group can be methyl, ethyl, propyl, like that. Similarly, if you go for AR group, AROH, then it is called as an aryl group, aromatic. All that will be done in the next part. Now, what we have to understand, with this basics if you go, then the naming part and understanding the compounds will become easier for you. That means, in alcohol, the general formula they give is ROH, alkyl with the hydroxyl group. And these are classified into two major types. What are they? Depending upon the number of OH groups, if only one OH group is available, then they are called as monohydric alcohols. Hydric, they wanted to say that OH group. So only one OH group is available, they are called as monohydric. If more than one OH group is available, then they call them as polyhydric. Polyhydric, let us have, so I can see more than one OH group is available, then we call it as a polyhydric. Example, first one, we talk about glycol. Glycol is coming under dihydric. I hope boys you are able to understand the meaning. Di means 2 OH group. The formula of the compound CH2, double bond CH2, you break one of the double bond and in that place you attach 2 of the OH group. Then ethylene glycol, 2 OH groups. So if you closely see the molecule, it has 2 OH group, that's why it is coming under dihydric alcohol. And if you talk about glycerol, glycerol is trihydric. Trihydric example, glycerol. So the molecule has 3 hydroxyl groups, CH2OH, CHOH and CH2OH. If you closely see 3 OH group, that is fine, and they have a difference, that is CH2 group is here and CH here. Then we will be learning about primary alcohol and secondary alcohol in this area. And it can be made 4 tetrahydric, pentahydric and hexahydric. I will give you example of sorbitol. Hexahydric. That means 6 OH groups may be available. And if you take glucose, fructose, they have 5 OH group, pentahydroxy. And I write the CH2OH and CHOH 4 times and CH2OH. So if you closely see 1 plus 4 plus 1, 6 OH groups are available. And these are having more than one hydroxy group, so we talk about polyhydric alcohols. This is one category. We will be learning about individually the compounds too. Now monohydric, again it has a further classification. What are they? As I told you, monohydric alcohols carrying only one OH group, they can be with only alkyl groups alone attached on the left hand side. Again you may be asking, alkyl group means it's a methyl group, ethyl group. No, there again one more classification is available. The group is a primary alkyl group or secondary alkyl group or a tertiary alkyl group. All these comes under sp3 type of hybridization. And monohydric, another classification is sp2 type. What is sp3, what is sp2? While discussing the structure of OH group, I will give you exactly. Now sp2 hybridized, there is a possibility of unsaturated compound. The best example is vinyl alcohol. Here this particular compound is sp2 type of carbon. The OH group attached carbon is sp2 type. Then we talk about the monohydric and the sp2 type of carbon linkage. But all these people are sp3 type of linkage. And in that particularly we are going to talk about primary alcohol. Let me write an example, you will understand better. I just gave you in the introduction, imagine it is an hydrocarbon, methane. One of the hydrogen I am replacing with the OH group. And this side, hydrogen I can replace with one of the methyl group. If you closely see the structure, this molecule can be written like this: CH3, CH2 and OH. This is nothing but ethanol or ethyl alcohol. Now, only one R group is attached to one side, so it is primary, and the other side OH group is attached, and leaving that, the carbon, the sp3 hybridized carbon is CH2 in nature. This is the part you have to understand. If the OH is attached to your carbon, which is CH2 in nature, then we talk about the primary alcohol. And if it is going to be a secondary alcohol, the same story only. Look at this. One of the sides OH group is attached, and other side already methyl group is attached, and here the hydrogen is attached. So in the place of this hydrogen, I go for one more methyl group. So totally number of methyl groups attached are 2 in number, we call it secondary. And if you closely see, the structure is a CHOH. Wherever you see the functional group is an alcohol, that alcohol is attached to a carbon that is CH in nature, then we have to talk about 2 degree, that is secondary alcohol. In case the next category, the same thing will have carbon, one side OH group is attached, it's an alcohol, and left hand side as usual a CH3 group is attached, and here I attached for a secondary one CH3 group, and there was one hydrogen available. Even that hydrogen I changed it into a CH3 group. Now you closely see total number of alkyl groups or methyl groups attached are 3 in number. It may be methyl, it may be ethyl or propyl, any of the alkyl groups. So R groups 3 in number tertiary, but leaving all these 3 R groups, look at the general structure of the OH attached carbon, it is a COH. That means all the 3 sides with the alkyl groups. And if this is the structure, then you talk about tertiary. And we will be dealing with this particular primary, secondary, tertiary very deeply, because these hydrogens will go for reactivity in certain cases, and that will differentiate the primary, secondary and tertiary. For example, here the OH attached carbon is called as alpha carbon. That alpha carbon has 2 hydrogens, so we say 2 alpha hydrogens are available. And the OH attached carbon here secondary, as I told you, it is alpha carbon. And now you closely see that carbon, here it is attached to the 2 hydrogens, but in this case it is attached with only 1 hydrogen, so only 1 alpha hydrogen. And if you go for tertiary, the OH attached to carbon is not having any hydrogen at all, so he is not having alpha hydrogen. So this will make a lot of changes in the reactivity. So in primary, secondary, tertiary, as I told you, 1 degree, 2 degree and 3 degree, if the OH attached carbon is CH2 in nature, it is primary, CH in nature secondary, and if the OH attached carbon is COH, it is tertiary. Okay, alkyl groups may differ. And when we talk about alene or allyl group, what is alene gas? The CH2 double bond C double bond CH2. This is alene gas. and one of the positions we add an alcohol, then it becomes allyl alcohol. By breaking the bond, add a nitrogen here and OH group here. So this is called as allyl alcohol. The allyl alcohol structure also, if you closely see, CH2 double bond CH and CH2OH. The allyl group, it is fine. The OH attached carbon you have to look carefully. If you look at the carbon, it is primary in nature. So that is why it is coming under primary category. And suppose this hydrogen, one of the CH2, I am separating the hydrogen. This hydrogen you remove and add one methyl group. See, look at the next possibility, CH2 double bond CH single bond CH, and that OH group is available as such. I am not disturbing it, but in the place of this hydrogen I am going for one methyl group. Then it is no longer primary, it has become secondary, that is CHOH. And as a secondary allyl alcohol combination. Next the thing is I am going to attach, in the place of this hydrogen I go for one more methyl group on the top. The OH is attached to a tertiary carbon. So in allyl alcohols also we have primary, secondary and tertiary. Let the compound be like this, we will be learning. And we talk about the benzyl group. What is the benzyl group? We know benzene. What is benzyl? And if you closely look at this molecule, C6H5CH3, this is called as methyl benzene, otherwise called as a toluene. And this carbon, one of the side chain hydrogen attached to the carbon is removed and one OH group is added. And in that case, if you see the molecule C6H5CH2OH, this is exactly benzyl alcohol, this is benzyl group, this is alcohol. That benzyl alcohol is having CH2OH, so it's very well known to you. It's coming under primary alcohol. And if you one of the hydrogen I remove, you attach one CH3 group. When hydrogen is removed, CH3 is added. Obviously this will get converted into a secondary alcohol. And if you go for removing this hydrogen also and add one more methyl group on the top, the earlier formula was like this, and one of the hydrogen is removed and one CH3 group is added, then this gets converted into tertiary. So every of the class of organic compound we have to understand something about primary, secondary and tertiary. And these compounds can be named both the common name and the IUPAC name. And let us learn one by one by understanding the rules of IUPAC in the next part. And for example, I am giving you this compound is the first alcohol, that is CH3OH. As you know, the common name says that you have to talk about alkyl group and finish the name with the alcohol. So the name of the alkyl group, since it is having one carbon, it has to start with the methane. And it is not CH4, it is not methane, it is only CH3. It has lost one electron. So we are adding YL, methyl. And you attach one OH group, then OH group in the place, I am calling it as a methyl alcohol. It's a common name. And you may be asking what is the IUPAC name. If one carbon atom is available, the name starts with methyl. If it is single bonded, a saturated compound, the name ends with the ane. We learned in the beginning. And the rule for naming alcohol says that remove that E and add OL. So methane with alcohol, sir, why to add OL? And the name alcohol ends with OL, then you have to add at the end OL. Now the name of the compound becomes methanol. Similarly, we can name this. 2 carbons are available, ethane. I am writing. IUPAC name will be very standard. It won't be confusing you, and because it is following the rules. So International Union of Pure and Applied Chemistry. So a standardized system of naming. So you won't be getting any confusion, but you have to learn the rules. You have to strictly follow them. And 2 carbon atoms are there. The name starts with the eth, and everybody can name. These are all very easy. And as I told you, if single bonded, the name ends with the ane. It is a saturated hydrocarbon. But in the place of one hydrogen, the OH group is added. How to name them? Remove that E and add OL. So it becomes ethanol. These are the basics. We'll be learning one by one the names.